So we're on adjoint of matrices. Adjoint of matrices has something to do with cofactor. It's defined as the adjoint of a matrix is the transpose of the cofactor matrix. Yes. So meaning that for you to find adjoint, you need to find cofactor and transpose it. And for us to calculate the cofactor of a matrix, we need also to get the minors. So it's a long process. From minor, you get the cofactor and finally transpose it. But for 2 by 2 is easy. Like if you are given this matrix, the transpose is just the adjoint is just cofactor transpose. So if the cofactor matrix is C equals C11, C12, C21, C22. So once you transpose it, the transpose is now interchanging row and column. So that's it. So, but we still have a special formula for adjoint of 2 by 2 matrix. You don't need to waste your time going the long process. So let's calculate adjoint of a 2 by 2 matrix. It's direct. It's very simple to calculate. We are given this 2 by 2 matrix and we asked to find the adjoint. So we need to find the minor first. So to get the minors, so the minors for the first element M11 is, remember, deleting first row, first column. So we have B22 for M12, first row, second column. We'll have B21, M21, that's second row, first column. We have B12. And finally, M22, we have second row, second column. We have B11. So we've gotten our minors. So our cofactor, remember cofactor C11 is minus 1, 1 plus 1, M11. So this is positives. So this is now B22. So for C12, so this is already negative. That this is positive. So C12 will be negative. So negative is negative M12, which is minus B21. So for C21, this is already negative. No need. So you have minus M21, which is B1 minus, so minus B12. And finally C22. So this is already positive, so positive M22, which is B11. So our adjoint, okay, our cofactor matrix is now C11, C12, which is B22 minus B1, B2 minus B1 minus B21 minus B12, and finally B11. So let's transpose it. We've gotten cofactor, so therefore the cofactor transpose. So let's transpose it, which is now B22 minus B21 and minus B1 minus B12 and B11. So you observe that to get the adjoint is just, see, you interchange the elements of the principal diagonal. So do you see it? We have B22 here, but this is we have B11 and what is there is B. So it's the same thing as interchanging the element of the principal diagonal. You swap. And finally, you negate the other diagonal, the element of the other diagonal. See it. What is here is positive. What we have here is negative. What we have here is positive. Or what we have here is negative. So to get the adjoint of 2 by 2 matrix is very, very simple. So look, let's use example. Okay, example, we're asked to find the adjoint of the following matrices. So since it's 2 by 2 matrix, it's very simple to calculate the adjoint. The adjoint of A, which is C transpose, is very simple. Remember what I told you. Remember this. It's just to swap. See, you swap the element of the principal diagonal after you negate the other diagonal. So without wasting time, it's just this 2a, so it should be 8-2. And since this is 3, this is minus 3. And finally 5. So that's our answer. So for the second one, adjoint of B, written adjoint B is C transpose. So the same way you swap the element of the principal diagonal, which is minus 6, 9, and negate the other one, so minus 7, 3. So that's our answer. It's very simple. But for 3 by 3 matrix, solve normally. So example, let's calculate the adjoint of this matrix. So for the first one, which is C11, first element, C11 is minus 1, 1 plus 1, M11, which is M11 deleting first row, first column, first row, first column. So we have determinant of 5, 6, 4, 1, which is 5 minus 24, which is minus 19. So for C12 is minus 1, 1 plus 2 minus 1, 1. And this is negative, so negative of the determinant. So with so this is 1, 2, sorry. This is 1, 2. So this is negative of the answer. So deleting first row, second column, first row, so 4, 6, 1, 1, 4, 6, 1, 1, which is, instead of 4 minus 6, is now 6 minus 4 because of the negative sign. So 2. C13 is minus 1 raised to power 1 plus 3 M13. So this is positive already, so no need. So first row, third column, so we have 4, 5, 1, 4, which is 16 minus 5, 11. For the second row, so C21 is minus 1, 2 plus 1, M21. So we have minus second row, first column, second row, first column, 1, 2, 4, 1, 1, 2, 4, 1, which is, instead of 1 minus 8, it's now 8 minus 1 because of the negative sign, which is 7. Formally it's 1 minus 8, but due to the negative sign, it's now 8 minus 1. So because of this, we'll be subtracting this diagonal from that one. So the next one, C22, is minus 1, 2 plus 2, M22. So this is second row, second column, second row, second column. So 3, 2, 1, 1, 3, 2, 1, 1. So which is 3 minus 2, which is 1. C23 is minus 1, 2 plus 3, M23. So which is minus second row, third column, 3114, 3114. So which is now 1 minus 12. 1 minus 12, which is minus 11. So C31 is minus 1, 3 plus 1, M31. So this is positive already. So 31. Third row, first column. So 1, 2, 5, 6. 1, 2, 5, 6. So we have 6 minus 10, which is minus 4. So for C32, this is minus 1, 3 plus 2, M32, which is negative of the determinant. So third row, second column, third row, second column, third row, second. So 3, 2, 4, 6. 3, 2, 4, 6. So instead of 18 minus 8 is now 8 minus 18. So which is minus 10. So the last one is, so the last one, which is C33, is minus 1, 3 plus 3, M33, which is just the determinant. Third row, third column. So 3, 1, 4, 5, which is 15 minus 4, 11. So we've gotten all the elements of the cover. So we now have the matrix. Therefore, our matrix, which is C equals C11, C12, C13, C21, C22, C23, C31, C32, C33. So the matrix is now C33 is 11, C11 is minus 19, minus 19, C12 is minus, is 2, is 2, C13 is 11, is 11, C21 is 7, C22 is 1, C23 is minus 11, C31 is minus 4. C32 is minus 10. So this is our cofactor matrix. To find the adjoints now, therefore the adjoint of B, which is now the transpose of C. So we need to transpose this. So which is now C transpose is minus 19 to 11, 7, 1 minus 11, and finally minus 4 minus 10 11. So this is our adjoint.